Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on probability, lecture number 10, in which I will solve some miscellaneous problems on probability. Now, we solve a problem. Problem is, what is the chance that a leap year selected at random will contain 53 Sundays? Since we know that number of days in a leap year equal to 366 days, one day more than normal year, and number of days in a week 7 days. Now we divide 366 by 7. 7 5s are 35. 1 6, 7 2s are 14. 2 remainder. Therefore, 366 days equal to 52 week, 2 days. Since in each week we get a Sunday, therefore we must get 52 Sundays in 52 weeks. Now, remaining days are 2. Here, remaining 2 days. These 2 days may be Sunday, Monday, or Monday, Tuesday, or Tuesday, Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday, or Saturday, Sunday. If we collect these and we may make a set, that set will be sample space. Sample space for 2 days to be Sunday, Monday, or Monday, Tuesday, or Tuesday, Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday, or Saturday, Sunday. Here we get number of elements in sample space. Equal to 7. Now event. Event is a set which contains all those elements of sample space which contains Sunday. Here Sunday, Monday. So this element will be an element of event. Here Saturday, Sunday. So in event, number of elements in event equal to 2. Therefore, probability for a Sunday equal to 2 by 7. Since already we have 52 Sundays here, and here we take one Sunday. Therefore, probability for 53 Sundays equal to 2 by 7. Now we solve the next problem. Problem is, if 4 coins are tossed, find the chance that there should be 2 tails. We know that if we toss one coin, we get the outcomes head or tail. And the collection of outcomes be the sample space. Here outcomes are head and tail. So if we collect head or tail and make a set, and that set will be the sample space for tossing one coin. Therefore, sample space for tossing one coin is a set containing head or tail. Now, sample space for tossing 2 coins. For this, we take sample space for tossing one coin, Cartesian product, sample space for tossing one coin. And this is HH, HT, TH, TT. These are the outcomes or elements of the sample space. Here we get 4 number of elements. We may also find this number by taking number of elements in a sample space. 2 multiply 2 equal to 4. Means 2 square equal to 4. Similarly, sample space for tossing 3 coins will be Cartesian product of sample space of one coin thrice. And this is HH, HTH, THH, TTH, HT, HTT, THT, TTT. This HTT means in the first coin head, in the second coin tail, in the third coin tail. A number of elements for tossing 3 coins may be obtained by multiplying the number of elements of a sample space for one coin to multiply 2 thrice, and this is 2 to the power 3 equal to 8. Similarly, number of elements in a sample space for tossing 4 coins will be 2 multiplied by 2 multiplied by 2 multiplied by 2, that is 2 to the power 4 equal to 16. Now our task is there should be 2 tails. On the basis of this, we will frame the event. Here we see that for tossing 3 coins, means in each element we get 3 entities. Similarly, for tossing 4 coins, each element of the sample space will contain 4 entities. Means 1, 2, 3, 4. Now, out of these 4 places, we should have 2 tails. That tails may be in the first place, in the second place, and rest place head, or in the first place tail, in the third place tail, rest place head. In this way, we take 2 places out of 4 places, and this is the number of elements for event. Therefore, number of elements in event equal to, here 4 place we have to select 2 place. Selecting 2 place is the matter of combination. That means out of 4 places we have to select 2 places. This is the number of elements in event. Therefore, probability for event is 4C2 by number of elements in sample space, 2 to the power 4. This is 6 and this is 16, means 3 by 8. Now we solve the next problem. Problem is the first 12 letters of English alphabet are written down at random. What is the probability that there are 4 letters between A and B? Here we have 12 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have to write first 12 letters of English alphabet in these places. So, number of ways to write these letters will be factorial 12, means 12 letters will mutually exchange the places and we get this arrangement of 12 letters, and number of ways will be factorial 12, that is number of elements in sample space equal to factorial 12. Now, restriction is that there are 4 letters between A and B. If we write A in the first place, we have to write B in the 6th place, because between A and B we may write 1, 2, 3, 4 letters. In the similar manner, if we write A in the place 2, we have to write B in the place 7. In this way, we will go forward, and lastly, if we write A in the place 7, then we have to write B in the place 12, because between these we get 1, 2, 3, 4 places. So, this process of writing is the letter A going forward to place 7. The process is that the letter A is starting from the place 1 and going forward to the place 7, and number of process will be 7. Again, letters A and B may mutually exchange the place, and this process is factorial 2. Means we have 2 letters will exchange with each other, that is number of ways is factorial 2. Again, we have to select 4 letters to write between A and B out of 10 remaining letters. Here we have already taken letters A and B, remaining number of letters be 10. So we have to select 4 letters out of 10 letters. That process is selecting 4 letters out of 10 letters. This is the matter of combination. And after selecting, we will have to rearrange these 4 letters. Rearranging the 4 letters is number of ways is factorial 4. And in the remaining places means remaining 6 places, remaining 6 letters will mutually exchange or rearrange themselves, and that process is factorial 6. Since all part of works are done simultaneously, therefore we multiply them, number of process. So this is the number of elements in event. Therefore probability equal to number of elements in event 7 multiply factorial 2 multiply 10c4 multiply factorial 4 multiply factorial 6 by factorial 12, and this will be 7 multiply 2 multiply factorial 10 by factorial 4 factorial 10 minus 4 means factorial 6 multiply factorial 4 multiply factorial 6 and here factorial 12 denominator. So if we cancel this and this and this, here factorial 10, here factorial 12, so remaining be 11 multiply 12, so this equal to 7 multiply 2 by 11 multiply 12, and this is 7 by 66. Now we solve the next problem. Problem is 8 letters to each of which corresponds to an envelope are placed in the envelope at random. What is the probability that all letters are not placed in the right envelopes? Here we have 8 envelopes and letters are to be placed in the envelopes. If we place the letters in correct envelopes, then that process will be correct process. Otherwise, remaining process will be incorrect process. So firstly we have to find the number of elements in sample space. To find the number of elements in sample space is rearrange 8 letters in 8 places. So number of elements in sample space equal to factorial 8. One process is the correct process. This process is to place the letters in correct places or correct envelopes. Therefore, this event is called E, NE equal to 1. Therefore, probability for placing right letter in right envelopes equal to 1 by factorial 8. Therefore, probability for not placing the right letter in the right envelope equal to 1 minus 1 by factorial 8, and this will be 1 minus 1 by factorial 8 is 40320, and this will be 40319 by 40320. Now we solve the next problem. Problem is the probability of a horse A winning a race is 1 by 5 and probability of a horse B winning the race is 1 by 4. What is the probability that number 1, either of them will win? Number 2, none of them will win. Here let the event of winning by horse A is denoted by E1 and the event of winning by horse B is denoted by E2. Therefore, PE1 probability for winning the horse A equal to 1 by 5 and probability for winning the horse B is 1 by 4. It may be possible that there are another horses also, but we are considering here only 2 horses. As in the race only one horse will win, that may be horse A or horse B or any other horse. Here no 2 horses may win together. Only one horse will win. So E1 and E2 will be mutually exclusive. E1 intersect E2 will be mutually exclusive. So probability for winning both horses is 0. Number 1. Either of them will win. Either means E1 union E2. PE1 union E2 is PE1 plus PE2 minus PE1 intersect E2. This is equal to PE1 is 1 by 5, PE2 is 1 by 4 and this is 0. This is 20, 4 plus 5, this is 9 by 20. This is number 1. Now none of them will win. Number 2 means E1 will not win. That means complement E prime E1 prime intersect E2 means horse B will not win together at the same time, and probability of this is P by De Moivre's theorem E1 union E2 whole prime, and this equal to 1 minus P E1 union E2, and this equal to 1 minus 9 by 20. This is 11 by 20. Now we solve the next problem. Problem is, what is the chance of getting 7 or 11 in a throw of 2 dice? Since for throwing 1 die we get sample space having elements 1, 2, 3, 4, 5, 6 elements. So for getting sample space for throwing 2 dice will be Cartesian product of the sample space for 1 die twice. So number of elements in sample space for throwing 2 dice will be in Cartesian product of a sample space for 1 die twice, and we have to get the number of elements in this Cartesian product, and that is 6 multiply 6 equal to 36. Now, question is that the chance of getting 7, since each element of the sample space is of the form of ordered pair. So, here ordered pair 1 6, 1 plus 6 7. Similarly, 6 1, 6 plus 1 7, 2 5, 2 plus 5 7, 5 2, 5 plus 2 7, 3 4, 3 plus 4 7, 4 3, 4 plus 3 7. These are 6 elements in the event E1. E1 be the event for getting 7. So NE1 equal to 6. Let the event of getting 11 is denoted by E2, and E2 will be the elements ordered pair 5 6 and ordered pair 6 5. Number of elements in E2 be 2. Therefore, PE1 equal to NE1 by NS, number of elements in sample space. NE1 is 6 by 36, means 1 by 6. PE2 equal to NE2 by NS. NE2 is 2 by 36, and this is equal to 1 by 18. Since E1 intersect E2 equal to 5, there is no common element in E1 and E2. Therefore, PE1 intersect E2 equal to 0. Now we have to find the chance of getting 7 or 11, means we have to find the probability of E1 or E2, means union. PE1 union E2. This is PE1 plus PE2 minus PE1 intersect E2, and this is equal to 1 by 6 plus 1 by 18 minus 0. This is 18, 3 plus 1, 4 by 18, means 2 by 9. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.